Hey, welcome. We're always getting started the lectures like this. And this says, you know what it says? You know it already? It says respect. This is a coordinate system. This shows that the positive rotation order. I do that for two reasons. First of all, I'm going to introduce you the three-dimensional rotations, not this week, but the weeks to come. And then the real actual reasons to use that is that I'm every now and then I'm editing my lectures, editing my videos that comes out from the YouTube. And this is a sign to say, okay, everything before that is just a big mess because of the settings and so on and so forth. So, hey, welcome to class entitled Simulation of Mechatronic Machine. My name is Aki Mikkola. I'm going to be your teacher in the lectures. And this year I have a really good set of other teachers. I'm going to introduce those to you momentarily. And there they are. So I'm the one mentioned up in this list. My office is located in a building number 6 is the 7th floor. So you can come and knock my door anytime you want. You can always send me an email. I wanted to promise you 24/7 response time, but it's not able that I can do that, but I can try to respond to you as frequently as possible. And I'm here together with other teachers. So we have a fantastic guy, Alfonso. Alfonso, if you can come here so then the online participants can see you. So here's Alfonso. Alfonso has a very big brain, so he's very clever in multi-body system dynamics. And you get to know Alfonso in these guided tutorials,
yes.
Weekly guided tutorials. Then I have here very strong guy, Mustafa. Mustafa has a big muscles, including the brains. Mustafa is here. Mustafa is taking care of the simulation assignment and creating some of the work in this class. And then finally we have Mudica. Mudica, can you come please here? So the newest member of our team, he's taking care of the Moodle and things related to that, but not this week because we're still struggling with your contract. But your contract will be up and running next week?
Next week, yeah.
Okay, good thing. So these are the teachers, and you're going to get to know them a little later. So how is YouTube? Is it going well?
Yes.
Also, I need a little bit of your help. So those of you that are coming with computer or iPad, we need to select somebody that is called YouTube officer. Would you like to be a volunteer to be a YouTube officer?
Sure.
Fantastic. You can put it in your CV. So it's a YouTube officer simulation of mechatronic machine class 2025. So what comes along with this YouTube officer position is that you need to take a look at the comments because I'm unable to see the comments for online participants. They might have something. Usually they don't because in Finland we don't communicate. But they have this opportunity to write things down so they can put things in writing. And if there's any comments, let me know. If there's any questions, comments. Usually the comments are like, the connection is not good. This is the typical connections. Never ever asking much of a questions, but they might. Okay, guys, you can go. So we're going to see you a little later. So I will continue with the rest of the class here. We're going to discuss about matters related to multi-body system dynamics. Good thing. So it's going to be an hour and a half. Exactly. Hour and a half.
Go to YouTube.
Oh, yeah. So you need to.
A Mechatronic machine.
Yeah. So you can search.
You can find this guy's picture.
Yeah. Nice. All right. This is what's going to happen today and weeks to come. So here are the subject matters for first 6 weeks. And today is the most important lecture, definitely. Because we're going to set something that is called ground rules. Ground rules is how you can pass the course. What are the requirements? What are the different ways you could pass the course? So that's what we're going to discuss today. And then not just that, but some other stuff as well. So I'm going to also introduce you a little bit about the content of this course. Like why it makes sense to participate in this class. Why this course is good for you, and why it matters maybe more than you think that it matters. And then we're going to continue with the mathematics needed in the course. Yes, we do need some mathematics in this course. And yes, it's all about this nasty matrix operation, partial this, partial that. But that's okay because we're gonna go slowly. I'm gonna hold your hands, and we're gonna go in a way that you can all understand what we're speaking here. All right, but we still need some mathematics. and just a little bit about how you can refresh your mathematical skills. And then finally, description of rigid bodies. Real deal. That is when things really getting started. And already this time it's good you to be aware of that we're gonna get started slowly, but the speed will progressively increase, and it increases a lot. So that means that you may think that, oh my God, this is so easy, I know this already back and forth, I don't need to come to lectures anymore. Don't do that, because you skip a week or two, and when you come to the lectures, you're not able to find your way out from this lecture room by yourself. You're so confused, like you're here standing in a corner, like, how did I came in? So that will happen to you. So make sure you're following me. All right? Good thing. So, and take a look at the subject matters we're going to discuss. It's a pretty nasty stuff. Something like virtual displays and virtual works, analyzed extended applied forces, and matter similar like that. What do you think? Okay. It's going to be a lot of fun, I think. This is how we're going to continue. There's going to be actually lecture number 7, which is going to be just before the midterm exam. That is recap, summarizing what is it that I'm expecting you to know in a midterm exam. Okay, but without further ado, here it is. This is grading. This is how you can pass the course. And I emailed you yesterday. The same material was in my email, and it goes like such that we have a total of 3 different things how you can collect the points. You can collect the points from written exam, which is worth of a total of 40 points. You can participate 2 midterm exams, and this is the one way you can get a max of 40% of the points. Then there's something that is called weekly homework, one of the easiest way to collect the points. This is something that I'm gonna give you the first weekly homework later today. If not today, then it's gonna be tomorrow morning. And then you need to submit that using the Moodle website, database. I don't know what the Moodle is called. Anyway, so that's gonna be the Moodle assignments that you have are usually 2 weeks time. So the one that I'm gonna open today or tomorrow morning at latest, going to be available, will be due on next week, Sunday night. So you have roughly 2 weeks time to complete the first weekly assignments. And the weekly assignments is a worth of 20% of all the points. And then there's finally a simulation work. That is something that I'm gonna offer you 2 weeks from now, 1 week from now, roughly that time. So you can start building your simulation model, putting things together already this time of the class. And again, worth of 40 points. And then comes something that you might have used to deal with earlier. This is something called in-class quizzes. And this is my way to communicate with you, because I'm sensing tense atmosphere. I don't know if I'm right about that, but based on your face, seems that we are not friends, which is a very pity. I'm very unhappy to see that, but usually this is the way it goes. There's not much of a communication, and I would like to have a communication. So you have the opportunity to ask from me, but you almost never use this opportunity. That's why I'm asking from you. So it goes in a way that I'm explaining something to you, and the next thing is gonna be a question, like how it goes. It's a multiple choice questions every time, and the one option only is correct. Okay, this is something that you're gonna get to learn a little later today. And I highly recommend it that you team up. I recommend you to set up WhatsApp group or something that you can communicate that say, hey, now there's in-class quiz, and I am the one that is knowing the correct answer. The correct answer is A, B, or C, or whatever, and this is something that is okay. So please team up, get to know each other, building the same class, and you can also make a comments about other stuff, because I do not have an access to this WhatsApp group that you might be able to set up, okay? Right.
So, sorry, we just have a comment, and it's just asking that are the recorded videos posted on Moodle?
No,
Okay.
because they're in the YouTube. There's a link to the YouTube.
Gotcha.
But I'm YouTube because I want to be rich and famous. So I'm almost there. So it's not much needed. But this subject matter, why wouldn't I? Look at what I just mentioned, virtual work and stuff like that. This is something that makes younger generation to go wild. All right. And I'm expecting the money delivery from YouTube any day now. So I don't know how I'm going to spend it. Probably going to purchase a Mercedes first and then something else, but we'll see. We'll get back to this a little later. Okay, so only YouTube. Only YouTube. Because there are people outside of LUT that are seriously, there is a people outside of LUT that are willing to follow these lectures. That is correct. That is correct. And they cannot if it is going to be in Moodle or if it's going to be Teams or something that is internal use only. Okay, good. All right. No previous knowledge required. Can-do attitude is needed. You can make it happen. You can make this all happen so we can all learn together, but you need to work with me. So we need to collaborate. And what I expect from your end is not just the can-do attitude, but the hard work. I think this is a little bit incorrect statement because it should be can-do attitude plus hard work. That's what is needed. That's really what is needed. I don't expect you know this subject matter in that, before the class. And I don't think there's anything similar than this anywhere else because we're going to speak about dynamics. We're going to speak about computational dynamics. And this is something that probably you have participated in the classes entitled like dynamics in your bachelor level studies, correct? But this is a different what we do here because we're solving dynamics using computer simulation. We are using a little bit of pen and paper, but just making some of the pieces that are needed in equations of motion, and that's about it. Okay, all right, lectures. The first thing, so this is related to midterm exams, written exams. So lectures every Monday, same place, same time, this particular time. You can also follow me online using this YouTube connection. That's one possibility. And the YouTube channel is this Multi-Body System Dynamics. Written exam, there's going to be 2 midterm exams. Unclear today how we can organize it. And this is unclear because we need to find a way to make sure that you guys are not using ChatGPT excessively. It's okay to use ChatGPT, but we would like you to learn something, not just the ChatGPT to learn something. And the possibilities are that we could organize the midterm exams in something that is called exam rooms. I'm not a big fan of that because usually we are allowing each student to have 2 attempts to each of the midterm exams. And I don't know if this is possible if you have this exam room. Then another possibility is that we could try to make ChatGPT to be confused, but I don't know if we can really do that. So today is unclear. So I will keep you posted. I will let you know how we can organize the midterm exams. And most probably next week, Monday or Monday after that, I will tell you the details, how we're going to do it. Sorry but I do know when they will take place. So they will take place in week 43 and week 50. And I really would like to see this thing that you have 2 attempts in those weeks. But how exactly, we'll get back to you. Okay? All right, tutorials, stay tuned. Alfonso will send you an email. We are not going to get started tutorials this week, but it's going to be next week. Not this week, next week. All right, it's going to send you an email. Tutorials is going to be a total of 12 weeks. There's going to be a 7 guided modeling task, that you will get to know how to use a software that is capable to solve dynamics. And this is the skill you're going to use when you have this simulation assignment. So this course is structured as follows. These lectures is to explaining you how is that this commercial software that you will use in a guided tutorials, how they work, what's the operation principle. Because you are master level students. For the master level students, it's not enough to be able to say, yeah, I can use, this is where the different icons are located and this is how I can do the clicking business. That's not enough. You need to understand what's the theory behind. You need to know what are the limitations of the theory, what this theory is capable of, and what it's not capable of, which is probably even more important information. So that all will be explained here in these lectures. And then there's more practical, like hands-on part of the course is how you can do these weekly assignments that are a little bit related, quite a bit of related to this theoretical thing, and then how to use, how to learn to use software solving dynamics for you. All right, so we're using Simscape software mainly. So there's a possibility to use a Mevia software as well, which is a real-time simulation software, but Alfonso is going to specialize to Simscape. And there's a good, there's a really good YouTube channel that is offering all the help to how to use a Simscape. This is made by a former teacher of this class, Dr. Suraj Jaiswal. And seriously, Suraj's YouTube channel is very popular. So he had more than 200,000 views. Let me repeat, more than 200,000 views. So that's a lot. My channel, nowhere near as popular. But anyways, I'm not envy, a little bit. But what are you gonna do? So he's explaining how to use Simscape, and it's fun to watch. All right? Weekly homework is getting started as soon as I'm posting the first weekly assignment module. And they're going to be available in this period and a little bit in second period as well. A total of 100 points available from that. Simulation work will be done individually, meaning that initial values, initial parameters will be student number specific. So you're going to get the specific numbers that are you only, and that's how it's going to go. And we are giving this assignment week 37. So help me. So what week is this week? Is it 36? I think it is 36. All right. So it's going to be next week then. In-class quizzes, a total of 24 points. And it's simply that you need to install something that is called Socrative. I hope that you have that already in your phone or your, I don't know how you're going to answer. But if not, you're not going to get these extra points. And these extra points, like if I go back, you know how it goes. This was this math table. So you get 40 points from the written exam, 20 points from the weekly assignment, 40 points from simulation work, and 10 points from in-class quizzes. So that's a total of 110. 110. You know this phrase that you commit yourself 110%. Here is actually possible to do that. But here is a word of warning. So you still can get a max of 5 out of this class. So I'm not going to send us any numbers to Student Affairs Office which says that you're going to score 6 out of 5 of this course, because then they're going to put me the sick leave. I don't want that to happen. So 110%. One of the easiest, if not really the easiest, way to collect the points in class quizzes. You just follow in the class. That's it. All right. So let's move on. So we are almost done with the ground rules. Simulation assignment, in-class quizzes. Yeah, in-class quizzes. Yeah, this is something that momentarily we're going to get started in in-class quizzes. The first in-class quiz will come soon, really soon. So I hope you will listen to me. Can you feel the pressure already? Because it's affecting your final grading. You feel it? Good. All right, so you need to log into Socrative and you need to select the room that is called LUT. LUT room. And you need to log in by using your student ID number, but please keep all the zeros in before the first digit, before the first non-zero number. So all the zeros, there may be 2, 3, sometimes even 4 zeros. Take them all off. Lock yourself into the system, because momentarily we need this. Good. Right. Again. Let me. I think there's all course material will be available in Moodle, so I don't expect you to read anything but material that is in a Moodle database. So that's my offer to you. I'm not expecting you to go to the library to do the literature review, nothing like that. All the material that includes a PowerPoint presentation, these streamed or these recorded lectures, handouts, and others that are in the weekly assignments that are in a Moodle database, those is what I'm expecting you to master. Okay? Yes, sir.
Mr. Are they supposed to keep the zeros or omit them?
You need to take them off.
Take them off.
Take them off. Take them off.
Okay.
So if there is zeros in your student ID number, usually it's getting started like 00, then a digit that is non-zero. Take everything before that off.
Okay, thank you.
So it's like if the first digit other than the 0 is 7, get started from the 7, and so on and so forth. Okay, so that's it. And then there's a fantastic material. This is really fantastic material that is called a Temeco. Don't know where this abbreviation is coming from, but anyways, familiarize yourself with that because that is seriously a good stuff. This is something that is helping you in many of the things that I'm explaining in my class. And it is highly recommended that you familiarize yourself to subject matters prior to the lecture using this Temeco website, YouTube site. This is YouTube too. And then in the lecture, I'm going to give you a little bit of different angle, a little bit of different ways to explain the same story. And that's how we're going to go week in, week out. Okay? Guideline. Guideline to pass the course. Like I say, trust yourself. You can make this happen. You can. You can. You have all the knowledge, you have all the skills to make things to happen. But this course comes with the pain. It's not going to be the easiest course. Some people claim that this is the hardest course LUT is offering in a master level. I don't know if this is true or not, but it is a fact that this hurts physically, this course. So once you pass the course, yeah, you can make some good celebration. You can walk in a moonwalking style like Michael Jackson a couple of days and make a big celebration if you pass the course. So make sure you will get some good credits to yourself. But it's going to be something that's going to be a lot of fun too. Those of you that I met, international student I met earlier last week, I said, university is giving you 2 packages. The one that is a networking, which this course is not going to be that strong because only this possible WhatsApp group, but we also give you the different way of thinking. This course is all about the different way of thinking. So I'm gonna stretch your brains. Your brains is going to be significantly bigger once you offer the course, and your thinking is going to be different than it was before that. Simply because we're going to look things in a very highly theoretical manner. So if you survive this, rest is downhill. I cannot say downhill, but it's just work still continues. But this is going to be the major milestone in your master level courses, master level studies. You need to follow the lectures and read the handout every week. Don't skip a week because that will come with a very big price. I mean, the very big penalties. So don't do that. Follow the lectures continuously every week. And it's really highly recommended that you even print out these handouts. You keep it all the time with you. So when you're traveling in the bus, you open the handouts and you read it. You go, I don't know, you have a break in a cafeteria, you read the handouts. If I see you to read the handouts, I'm going to be very happy, very proud of you. Okay? And do your exercises, do everything by yourself. This is something that I need to mention to you. In this university, the plagiarism is taken super seriously. There are 2 big crimes you can do in your life. Murder and plagiarism. Both never ever gonna go away in your life. Murder, the police go after you the rest of your life. Plagiarism, I go after you the rest of my life and your life. So don't do that. Go easy. I know that there's a high temptation. I can copy for my fellow student, but don't do it because the penalty and the benefit, they are not in a good balance. They just are not in a balance. So you should do a better crime than that. And I trust that you can make a better crime than plagiarism. Okay. So what do you guys say? My question to you, do you have can-do attitude? Yes. Okay. I know that this is hard to communicate here, but why don't we set the rules to communicate? So if you agree with me, you do this. Okay? You have a can-do attitude, and if not, you do it like this. And if you're really confused, you do like this. Like this? Okay? So which one it is? Okay, most of you like this, and some of you like, I don't know, it sounds like a little tough. Okay, first in class quiz, you guys ready? Is this? Please log in and answer the first in class quiz. How can someone pass this course? Through networking, because the networking was one of the big packages you can get from the university. I used to focus on the parties and stuff like that. This is the one opportunity, one option. ChatGPT is another. And then by putting in effort, like keeping up with the lectures and materials every week or even daily. Just take it easy. Aki's a laid-back guy. He would probably let me pass the course anyways because of my good explanation about this and that. Okay, so one only is correct. Which one is correct? No, I don't know. You guys need to go and vote. You need to enter your answer. You need to cast your vote. Okay. Should we take a look at how we're doing in this first in-class quiz? Okay, so it's going to be for online participants. It's going to be a bit chaotic because I need to jump from one window to another. So this is it. You see this clearly, I hope. So we got 134 students in this class, and out of that, 71 entered the answer. Okay. This one has to come with a 100% success rate. If not, what's going to happen is that I will go back to the slide number 1. And we are not moving forward. We're going to go this until we're going to score 100%. Okay, so those of you that are not sure what to answer, go and discuss with your fellow student because I'm serious about this. All right, so you guys ready? So we got 72 answers. Okay, success rate here today is, good job, good job. Yeah, nice. Are you guys listening to me or what? Look at that. Look at that. So we're gonna get started. We're gonna get back to this a little later, but now I'm gonna put it off, and I will hold on. I need to take myself here, and this is where we're gonna go. Good. Very good. So we were here. Can you take a look at that? The YouTube is looking okay.
Yep.
It's looking okay because sometimes it jumps back and forth, so it come with a little bit of surprises. Okay, introduction. Now is your opportunity to ask. Remember, you can collect the points in 3 different ways. Actually, you can collect the points in 4 different ways, but the one is like extra thing to collect the points, and that's in-class quizzes. But all clear. So no unclear matters. The one thing that is unclear is that what about the midterm exam? But as promised, I will get back to you a little later. So we just need to sort it out that like technicalities related to midterm exam. Okay, yes, sir.
You said that 2 midterm, so
Correct,
each
correct.
of them were 20% each.
No, it's not going to be like that. So we're gonna keep you. You need to participate in both. You need to participate in both, and then you're gonna get the gradings that is 0 to 5, and then we're gonna compute the average from these 2 midterm exams. Now that's how we're gonna give the points to you. Good question. Good question. There was something other than that I wanted to mention, but I don't remember what was it. Maybe probably not. Oh yeah, that's the thing. You know, you first, and then I will explain my thing.
Is there some sort of rule that if you don't pass the written test, you don't pass the course, or?
No, you just collect a minimum of 35 points, 35% of the points, and that's it. So you can do it any way you want. So if you don't like midterm exams, if you don't like a written exam, fine. But you need to do well in weekly assignments and your simulation work. But you can skip one of them. I know that some of you are thinking that I couldn't care this subject matter less. You know, I just hate this. Already I know this, even though that this is a first lecture, and that may be okay. You know, I mean, that's okay. And then you just need to use something that is called optimization, and something that is extremely powerful technique in the mechanics, minimum energy principle. That minimum energy principle, you collecting the points just to get the minimum. 35%, you go. You're out from the class. Oh yeah, and one thing that I wanted to say that what is highly recommended is that on YouTube, you can put the closed captioning on. You cannot do this while you're watching the streaming, but later in the recordings, you can put the closed captioning on. You can select any language you want. And that's highly recommended because I come with an accent. I have an accent, and sometimes you don't understand me because of subject matter is so unclear, or sometimes you don't understand me because of my way of speaking. Those are the two reasons. And if it is my way of speaking, put the closed captioning on, subtitles on, and that helps. And amazingly enough, YouTube can understand me, and it can make us closed captioning almost like all the time correctly. There are a few things that it goes incorrectly, but very, very, very few ones. Good. Good questions. Any other comments, questions? That's it? All right. So let's take a look at the introduction part then. And what I'm planning to do today is that I'm not sure if we could have like a short break once the introduction is done. Short one, just, brief break, and you go, you can get some refill into your coffee cup and then come back. But I would like to leave before 6 o'clock today. So that means that we are having these two 45 minutes lectures in more or less in a row. So we can have 5 minutes between, and then we can leave 10 minutes to 6 o'clock. That's my proposal. All right, introduction. So why it makes sense to participate in this class. A little bit about what is an objective of the course, and I partially explain this to you. So like I say, I'm explaining you the theory in a level that I'm expecting master level students to be aware of the theory. And that same holds for other numerical techniques, including finite element method. I'm hoping that you understand a bit more than just the clicking technique. You should understand like how this is, what's the method, what's the theory this is based on, and what are the limitations, and how are the basic principles of the method. Same here. So this is something that I'm hoping you to understand the basics, and that's going to be very powerful thing. And then a little bit about the hands-on things too, because simulation is not used for fun. Sometimes it's used for fun, like games are more like fun like anything else, which is one kind of the special case about what we're going to learn in my class. So those are real-time simulation. We will discuss about these subject matters too, but not very thorough way. And how it can be used in a different product processes in companies, because it's something that is quite a valuable tool, and it's good to understand that it can be used in multiple product processes. Typically, you might think that, okay, tools like finite element modeling. Well, the finite element modeling is actually basically used in a product development only, but the simulation tools you're going to learn in this class, they can be used in another product processes than product development. It can be used, of course, in a product development, but it can be used almost like all other product processes, also during the operation of machinery. And then in a service and retrofitting and stuff like that, it can be used. How exactly? We'll get back to this in the end of my class, end of my lecture series. And a little bit about how is that you can build the simulation model, what it means to have something that is called equations of motion. So what is the equations of motion representing? And you need to understand the difference between the linear and nonlinear dynamics. These are the basics. But it's extremely important to understand that. And then what are the advantages of simulation? Those are the things that I would like to explain today. Now, I don't want to repeat myself too many times, but yeah, we're going to take a look at the theories. That's why the lectures are painful. They are painful, but it's okay. It's okay. I'll try to make something that entertains myself. Probably is not, you guys are not going to laugh, but I'm going to laugh big time during the course of the explanation. But you will see that. We'll see it. Okay. How this is what is the potential of the computer simulation in a product development process and database businesses and other product processes? We're going to take a look at that. And the simulation model is representing reality, but it's not reality. What is the difference? Why is not one-to-one match with the reality? We're going to discuss about that too. And then you will learn to use the simulation tools. Alfonso will take care of that. And we're going to take a look at the system as shown here. So we mainly focus on mechanical modeling of mechanical components. But sometimes people seem to forget the fact that, equation of motion that is essentially saying that inertial forces equals to external applied forces. So you actually need to know just not just the inertial forces, but also the external applied forces. In mechanism, that means that, the method where I'm going to explain to you can be used to describe the mechanical components. Like if you take a look at this hydraulic driven crane, there's a 4-bar mechanism here. How to model the 4-bar mechanism, how to model this entire crane system here, that you can learn based on this box, which is called multi-body system dynamics. Now you need to know another engineering disciplines as well, which is how to actuate the mechanism. So 4-bar mechanism is not moving anywhere at all if there's not a hydraulic cylinder connected to it. How to model hydraulics together with the mechanical components, that's something that I'm going to emphasize in this class. I don't think we're going to touch much about the control system. We could, but we don't do that much. And then there's, of course, a user here, which can be accounted by using real-time simulation. So this is roughly what we're going to focus on. Like I said, I really want to focus on really a lot to say, this famous equation, F. I'm writing with my fingers, so that's why I'm clear writing. I'm hoping to get this iPad pen, because then it's going to be clear. It's not still going to be perfect, but better writing than this. And this is A. Have you seen this equation before? Okay, very good. This is what we're going to take a look. So this is what I say. These are the inertial forces, and this is externally applied forces. This equation is typically written in a way that D'Alembert said, D'Alembert figure out this. And he became to be world famous. So he simply substituted this in the left side of the equation, and he became to be super famous. Come on. Well, there was more than that. I will explain what more was that. But basically, if you are guessing this, you're also guessing this. Now, this is what we do in a computer simulation. We are actually solving this guy, which is an acceleration. An acceleration, we're going to use time integration schemes to get something that is called velocity. And for velocity, we're going to get something that is called position. That's how it's going to work. So we're going to first express the equation of motion, and then we're going to take a look at the acceleration. We're going to solve that, and simple like that. This is almost the course in a nutshell. There's one missing component that is called constraints. Because in this equation of motion, body can move as it wants. There is no constraint. Whereas in a 4-bar mechanism, you know that this is not the case. Each of the bodies moves with respect to the others. How to take that into account? We're going to focus that a little later then. But that. Oh, I need to do it like this. Okay. Good. This is what I said. Did I lost the no. What happened here? What the heck happened? So I had a good connection here, and then all of a sudden there's no connection at all. I warned some of you guys that there may be this case that, is it like because of the internet connection? Don't know. Was this cable connected or what?
I think it was.
It was connected, and then I took the connection off. So that explains. Sometimes this cable connection can make a big difference. Hold on. Now I have two ways that my screen is connected. I'm a little bit scared to. Okay, so we're gonna go with my computer then. And if there's a need to write more, I'm gonna do that after break. Okay. All right. This is what I just explained. External applied force equals to inertial forces. And that's what is called equations of motion. Okay, this is something that typically is called particle dynamics. We don't deal with the particles, but we deal with the bodies. All right? But again, this is something that I'm explaining you a little later. This is how it looks when we put this in a form that computer can solve the equations of motion for us. It is really that bad. It is really this bad. And it is this bad because the computers cannot deal with equations of motion any other means except the matrix and vector computing. And we need to convert the equation of motion to be expressed by matrices and vectors. And this is where the computer jumps in and solving the equations of motion in forward of time. And then what is the equations that are in the left side, excuse me, the right side of the computer are the ones that are describing the hydraulics. Each of them, believe me, each of them you will get to know during this course, during the course of this course. And surprisingly, it's going to be all clear in a few weeks' time. Okay. Then the computer simulation is actually accelerated learning process. And sometimes we can get something that is otherwise impossible to get. Biomechanics is a good application. We're doing biomechanical simulation because we want to computationally estimate some of the quantities that we are unable to measure from human body. And there are other examples where the measurements is not just possible. Can you, by the way, check that the streaming is still okay?
Yeah, the stream is fine.
So it was just my iPad that was jumping off. Okay. All right. Yeah, I don't want to have this video just to move forward. How to build the simulation models. I'm explaining you how to build the equations of motion using any software you want. You can use MATLAB or any other symbolic math tool you want, but this is what I'm explaining during my course. And Alfonso then in turn explains you how you can use a commercial software, because that is obviously the faster way to build the equation of motion and solve the equations of motion. Okay, so we're going to use Simscape, but you could use another software too if not happy with the selection of Simscape. And here is exactly where we are focusing on. This is showing the different product processes, which is usually getting started in the design and development. And then there's manufacturing, fabrication, quality assurance and testing, logistics and distribution. This is where we are not able to use a multi-body system dynamics or simulation. And that was the logistics and distribution. This is the only exception. All others we can. We actually can. During the operation we can. During maintenance, after sales support, yes we can. Retrofitting, recycling, yes we can. Each of them. Okay. So this is what I would like you to learn, that yeah, it is a tool that can be used in multiple product processes. I mentioned biomechanics a little while ago. This animation is an example about how we are measuring the bone strengthening process using the computer simulation. You see that there's a lower limb model where one of the bone, tibia, that is located here is measured as a flexible body. Tibia is surprisingly enough so close to the human surface, skin surface, that you could, in theory, measure the strains and stresses from this bone experimentally. But this is the only bone that is close enough to surface. And there are, even more surprisingly, there are experimental results available. How are the strains and stresses in a tibia of bone during the different kind of the exercises? So, why this is interesting? Because it's known by animals and athletics and other tests that a certain amount of strains and strain rates will make a bone to be stronger. So now the question is that what kind of exercise is good for your bone health? And you cannot just measure it, because you can only measure it here, but even here it's going to be painful like hell. Because what you need to get is you need to get a big knife, you need to make a cut here all the way until the bone, then you take a grinder, like this grinder, take all the flash away like until you will get a clean bone here. And then you attach the strain gauge to your tibia, you put all the skin back, take a lot of painkillers, and you walk. And then somebody's measuring the strain and strain rates. You cannot do this experiment. It's going to be very hard to get this permission from ethical committee to do it. I can tell you that. And this is not even the reason that is very interesting, because the reason that is way more interesting is the hip return. This is what matters a lot, way more than the tibia. Now, if you really want to put the strain gauge here, you need to get the really big knife. And when you got all the muscles off, you're not going to walk ever anymore. So that's it's not going to work this way. So sometimes there's another means to measure that hip region, but it's nasty like hell. All right, then this was like this kind of exercise machine that we can measure that, okay, how much this is affecting your bone health. How strong is your bones if you do this kind of exercises. Good example about what this simulation is capable of. And then let me see if I can go. This is a mobile machinery. This is a real-time simulation. So it's a little bit like a games. Now, real-time simulation is pretty much what you're going to learn, but the difference is that the solution of real-time simulation is synchronized real time. So you're making sure that you are not differentiating the running of the real time. And then you can read the signals from the joystick and so on and so forth. So this is eventually going to be a game. This particular game is boring, very, very boring. So no explosions, no nakedness, nothing that makes you guys to be excited. But this is something that can be used in other purposes. So this is something that can be used even in a product development purposes. Okay, this is another machine, also real-time machinery. So a few examples about what simulation is capable of. And then if we have any time left, I really, one of the favorite topics that I would like to explain to you is that what is the role of the artificial intelligence in the heavy machinery. This, of course, the examples you're going to take a look at here is not heavy machinery, but more academic examples about upright pendulums. But we keep these upright pendulums in this position using two different procedures. The one that is based on learning. So we're using technique that is called reinforced learning to learning the dynamics. And that's one possibility. And this reinforced learning is capable to keep up to the 4 bodies in upright position. So 4 beams that are connected together via frictionless revolutional joints. It can keep it in upright position. I don't think that any human can do that. You know, the human for the 1 beam would be enough. 2 beams may be too much. But this is something that artificial intelligence is capable to do. Problem, of course, is that it needs an awful lot of data. It learned to handle these 4 bodies in upright configuration, but the amount of simulation cases needed to learn that to artificial intelligence was 1 billion cases. Now again, I have these accents, so maybe you guys are not able to recognize. I'm not saying million, but billion. Not million, but billion. Okay, is it clear, or is it just ooh? It's clear, it's clear. Okay, good thing. All right, right. That's one way to keep this in upright position. Another one is based on something that is called faster than real-time computing. This is something that we're searching different opportunities to keep it in upright position. Shortly, it goes like this. You know, in real-time simulation, what we do is that we're synchronizing the computing to real-time. Real-time, if this is a real-time, moves with the constant speed. This is time moving forward. Okay, now in a real-time simulation, we started here. The simulation model goes here like immediately. Then it waits. And not what it waits until the time hits the same time. Real time hits the same time. Then it goes again, and it moves like this. Okay, that's how you do the real-time simulation. What if not waiting? Because the real-time simulation is, good percentage of the real-time simulation is nothing but waiting. Just waiting for time to hit the same spot. Okay, what if you're not waiting? You just go here. What is this? This is future, right? So this is future. You kind of have an ability to see what happens in the future. And when you have a lot of computer power, then you can have a multiple different motion scenarios. Each of them are projected to the future. And then there's an algorithm that is selected the most desired from for many possibilities. This is something that is adapt yourself to different configuration really easily. Okay, the best movie in a movie industry. What's the best movie so far we have ever seen? What's the best movie ever? Which one?
Avengers Endgame.
No,
Interstellar.
Terminator. Terminator. Have you ever guys seen the Terminator? That's the because I think that it should be made mandatory for people in a mechanical engineering, and you always need to vote Terminator when they ask like, what's the best movie? Is it or of course there's a debate about because the Terminator 1, 2, and 3 and so forth. So which one out of the many is the best? You can call Terminator 2. All right. Anyways, Terminator is this robotic system that adapts itself to different configuration. Must be based on this technology. That I don't know. Okay, anyways, so this is something that comes with a big promise, of course, but needs a lot of computer power. You need to have a lot of capabilities to run things in much faster than real time. Okay, so moving forward. This is actually an excavator that is not operated by any of the human. There's no human interaction whatsoever. This is based fully on reinforcement learning algorithm. It was a little bit of pain to learn it, and it's not very good operator. I would be better, because look, it's a little shy. It stops every now and then. It's not moving very good, but it can do the job, kind of doing the job. Now let me see what else. All right, this is an interesting thing. This is something that is very important to mention, because I have here one of the most followed stock index, which is called the S&P 500. And I'm showing this to you because I would like you to be aware of something that is extremely important for us. Something that is extremely important for us is that life is changing radically. And it's changing radically because business is moving from something that is called tangible asset to be intangible asset. Okay, you don't know what it means, but let me try to explain it in a way that, here is my phone. Tangible asset here is this physical phone. This phone, like this thing here. This is what is called something that you can touch. Intangible asset is all the apps that is inside of my phone. You cannot get them out. Even if you have a very, very big screwdriver, you cannot get the software out of my phone. You can destroy my phone, but still the software, you cannot get it out. You understand that? This is called intangible asset. This is something that is this relation between the intangible asset, something that is based on data, knowledge, branding, stuff that is not, you can touch with your bare hands. This role becomes to be increasingly bigger and bigger over the years in the stock market, just showing where the value is coming from. I know many people in the Department of Mechanical Engineering, when they look at this, they're like, oh my God, this is horrible, we're all gonna die. Yes, we're all gonna die, but not because of this. Because this is a good promise to us. This is something that is making our life even better. Because we here in this class, we are representing something that is knowledge, data, knowledge, intangible asset. So we can make things to happen. So we can make something that is supplementing to tangible asset, supplementing the hardware. And I believe on this. And because I believe on this, I see a lot of examples, a lot of it. Here's the most, this phone is a good example, but, television. I'm sorry, guys, you are so young that you don't know what is a television, but let me explain. So television is a big screen. It's like, something that is in a wall that every evening you go front of this big screen thing and you're watching TV news. That's what you do. That's a television. But television, if you don't have a monthly subscription of this and that, is no good. So television is almost like a license to spend more money. So because once you have a television, you also have to have a Netflix, you have to have a HBO, Disney Plus, and so on and so forth. This is a monthly subscription. So that's in addition to this hardware. And there's a lot of additional examples about heavy machinery. BMW. Any one of you use a BMW? Good. I'm happy. All right, that's a good news. All right, so no BMW. BMW, if you want to get the new BMW, there's a monthly subscription of heated seats. Come on, that's ridiculous. But there's examples like that, a lot of it, and that's something that business models is a one thing, but producing this data, knowledge-based products and services, that's us. We can make things to happen. So we can be the one that are changing this, or making the better business just like that. All right. In summary, yeah, and then we can have a very short break. I know you guys are tired already, and I need to set up my iPad. So this is the last slide before the break. A summary: simulation is shortcut to better products and services and business. Business may be missing here. So it helps to understand customer needs with the help of the real-time simulation. We'll explain it to you a little later during the course. And then it helps to produce new services based on data and knowledge. This is us, definitely us. So then product development time improves the product quality and performance, makes products to be more reliable. That's it. Okay, the next topic is about math. And the math is this simple. If you're shy with the math, use Khan's Academy. We will offer you like specific pages once we are hitting the road. You know, if you are not familiar with this and this operation, take a look at this and this particular Khan's Academy site. But you guys are familiar with the Khan's Academy, right? Very good website, very good in the mathematics. Good. And now, what I promised, can you handle in 5 minutes? Yes, I know that the team in the back row is very excited in 5 minutes. Good thing. Okay, see you in 5 minutes, and then I will set up my iPad, and then we're going to discuss about real deal. Real deal. Miten Jessellä menee? No mikä? Ai jaa. Missä oletko vielä töissä vai? Ai jaa. Okei. No sehän on hyvä homma. Mihin sä oot menossa? No niin. Sehän on hyvä idea. Joo. How can I help you guys?
He's not able to log in with
Okay, so you need to send me your so can I take a look?
Yeah, it's
So did you took these zeros away?
3264018.
Yeah, can you send me an email? Because this could be simply because of the late registration. Could be. Because I got the list of students that I took yesterday. So when did you enroll?
I did Thursday, like before 29.
Okay, so should not be that I don't know where it's behaving like that. Okay, let me mute myself. Okay, send me an email
I'll send it.
and I will sort it out.
Thanks.
Mm.
missä yhden luennon, että ihan niinku
Mutta ei sit haittaakaan ole. Okay, I need to know where you guys are from. So is it correct that the Team Finland is sitting in the front? You guys, oh my God! You know, this is very almost unprecedented thing, because Team Finland always in the back, sometimes outside of the lecture room. Most of the cases outside of the lecture room, but never in the front. So big respect to Team Finland. So what are the other teams we have? What are the other nationalities we have here? Mexico. So we have a Team Mexico. How big is a Team Mexico? Oh, is it not very big? So is there 2 members in the Team Mexico? 1 or 2? Is you only? Okay, so not very big team. What are you guys? Where are you? India. So Team India is big. Is it? Not that big. Oh, it's pretty big. Pretty big. What about the others? Team Finland, I can see, is in the middle too. What are the other teams? So is there the team in the back? Is that a Team Finland too? That kind of. So partially Team Finland. Very good. But unbelievable, this guy's in the front. This is the first time in my career. So what's up with you? Is this some kind of like a pet that you can sit in the front, or you just wanted to do it?
Well, just one guy's crazy.
It's kind of habit at this point.
Really?
Yeah.
Nice. Super nice. Super nice. So others? Pakistan and
Czech Republic.
Czech Republic. Very good. Very good. Very good. So how the Czech is doing in a hockey? Is it better than Finland? No. No. Okay. So hold on. Is it the streaming? Can you check if the streaming? I think that I need to do one more thing in my streaming. Is that post? Yeah, okay. I think that I need to make.
It's going on. Yes.
Yeah, this one.
It's working.
Refresh the page and you will get.
Can you check if it is okay now? Is it okay? So it's looking okay. Because it comes with a 10 seconds of delay, something like that. 10 seconds delay. All right, so now what happened is that we're going to start looking at how we can build the equations of motion. So we are making the step towards our big dream in our first part of the lecture season. We're going to spend the first 7 weeks to build the equations of motion. So we go slowly. We go slowly because I would like you to understand how it actually goes. Not just, I kind of know how it is, but I would like you to understand the details, why we do things the way we do things. That's my big dream. Okay, So, but I don't see the comment.
You don't?
I don't see the
there are
comment.
certain comments, and I'm not sure if I'll be able to answer them.
But what is this
So
asking?
it's asking is, we have 3 training Lapendranta groups in Sisu with different timetables.
Right. Yeah. This is
Tutorial.
tutorial. Correct. Good question. So again, one of the online participants asked, there's a 3 tutorials group. Which one to participate?
Yeah.
This is something that you need to stay tuned. Alfonso will let you know the details. There are typically goes such the way that one of these tutorials is something that Alfonso is there to really to help you to keep your hands and make sure you can do the task. 2 others are something that Alfonso is available, and it's your opportunity to ask from Alfonso. This is how it usually goes. I don't know how he's planning to organize things this year, but we're gonna figure that out. We're gonna figure it out once Alfonso is getting back to us. Good. All right. So, description of rigid bodies. So now we can open this subject matter that is called multi-body system dynamics, dynamic modeling. So that's something that follows in my slides to come. All right, so we're gonna first getting started by introducing you the multi-body system dynamics. As the title implies, is a method that can be applied if there is a system consisting of multiple bodies. Of course, you can use it if there's one body only. It's possible too, but it becomes to be very powerful tool if you have more than one body. There is by the definition, the multi-body system is a system that consists of multiple bodies, a system where the bodies are connected together via constraint, mathematical constraint. In real life, there is no such thing like mathematical constraints. In real life, they are calling joints. Joints that are limiting the motion possibilities of neighboring bodies, that's a multi-body system. And if you now look at the 2 systems that are here down in my slide, I have crankshaft mechanism, and then I have system that obviously consists of multiple bodies, this one here, but not having any constraints, having no joints. This one here consists of a 1, 2, 3 moving bodies. And the bodies can move with respect to each other in a certain way only. And that's simply because there are joints. The connection rod, that is this body here, cannot just rapidly go like here. Or if that happens, that it means that you have a major engine failure. But like if your engine is running properly, it will follow the crankshaft and a piston, the way these joints are asking it to follow. So that's something that obviously is a multi-body system. This is a multi-body system. This is not. Because these bodies, there's a multiple bodies, body 1, 2, and 3, but they connected together via spring, which is a force element. Joint is something that is stronger than any of these spring elements. So now, if I take a hold of the piston body and move it back and forth like happens in a combustion engine, the rest of the bodies will follow accordingly. And you can solve this deposition using something that is called kinematic analysis, using just art of motion and velocities. If you take a hold of this body, you compress it downwards, you cannot solve how is the position of the neighboring bodies by using kinematics, simply because they are connected using forces. Forces are spring elements that are located here. Now, we gotta focus on the system like this. You could solve this one here too, using multi-body system dynamics, but there are other means to solve the flexible structures like the one that is showing in the right side of my slide. Then comes a major addition, what I just explained. So far, if you take a look at close look about your lecture notes about Dynamics 1 and other bachelor level courses, you might have recognized this earlier, but one of the major assumptions you have made is that you are assuming the rotation to be small. Like, give you an example, the pendulum. Usually you have solved the pendulum by assuming that the motion of the pendulum is plus minus 10 degrees, like this much. We don't do the assumptions like that in a multi-body system dynamics. But instead, we can analyze the pendulum getting started here, going all the way here, or even rotating like this. Is that significant? Yes, it is. Because one of the most common sources of nonlinearity is a large rotation. Something we see in everyday life all the time, but the big difference is this. So if you really want to capture the large rotation of this pendulum system here, you must use a trigonometric functions, cosine and sine. Those are nonlinear functions, and you cannot solve it using analytical theories. This is just not, generally speaking, possible. And that's why once we put together equation of motion of this nonlinear system, we are unable to find analytical solutions for them. But we have to solve the responses as a function of time. That's what we do in a multi-body system dynamics. My next in-class quiz is about what is not the multi-body system dynamics. So again, the definition of multi-body system dynamics is that it consists of multiple bodies. The bodies are connected together via joints, different kind. You know, in a robotic system that there is a multiple different joints, and that's the kind of the system we're looking for. If there is no motion, if there is no joints, that's not the multi-body system. Clear?
So the spring itself here is not considered as a body, it's just a pure force?
Yeah, it's a pure force component. It's a force component. And that's because it's a force component. If you compress this body downwards, you cannot solve where these remaining bodies are located at based on kinematics. Kinematics is something that I'm not expecting you to know what it is, but I will explain it to you a little bit later. Basically, the kinematics already this time is good to you to know that is something we can solve the configuration of mechanism based only on constraints. Okay? Clear? So let's move forward. I need to click this. Okay. What is not the multi-body system? Let me explain what I have. I made this using ChatGPT, so the version that I used wasn't very good. So the first one is a biomechanical system. Second one is a robotic system. This is a front suspension of the car that value a total of 400 euros. And this is this very affordable car like this. Soon it's going to break from the front suspension. So this is for the team Finland because I heard that they just purchased a car worth of 400 euros. And it got the broken front suspension already. Okay, so it's a front suspension of the vehicle. And the final one is a simply supported beam. One is not the multi-body system, but which one is not? Okay, you see that this is how we're getting started. So easy, pleasant, laid back. Next week I'm asking you way more complicated questions than this. Okay, can you please enter your answer? And I will take a look at that momentarily, not right now because my system is up and running, so I will take a look at that later in my class. Okay? Clear? So did you already enter?
Yes.
Okay, and it's okay to communicate. You can communicate. So anyone coming here next to me, I will tell you like what is the correct answer, but you need to come here, physically here. I will step off from the camera, but if you come and ask like, okay, what's the correct answer? I will absolutely tell you, but you need to play with me. Okay. Okay, let's take a look. So multi-body system, now we know what it is. So it consists of multiple bodies. This is like more like mathematical representation. What is a multi-body system? So multiple bodies that are connected together via joints. And these joints we can describe in this multi-body system dynamics using constraint equations, which is typically, you're going to learn how they are, but they are constraint equations that are limiting the motion possibilities. And that's something we will take into account in equation of motion. All right, now if we take a close look about one body only, we are assuming that the one body consists of particles. The particles are something that is you cannot see in real life. This is a mathematical thing. But we are assuming that the body consists of very, very small particles. Something that is so tiny, so it's really, really small. Because it's so small, it's not having rotational degrees of freedom. Because think if there's something small enough, rotational degrees of freedom becomes to be immaterial, insignificant. Now that's an assumption we do. So we are looking at these very, very small dots, points. And when we have a lot of them, actually each of the bodies will consist of infinite number of particles. Once we have this infinite number of particles, then all of them will make a body. Body is then connected to the next body via joints and so on and so forth. That's how the system goes. Now we have a challenge here. Challenge is how to describe this guy, particle, with respect to something that is called reference coordinate system. Because dynamics is all about describing something with respect to reference coordinate system. Typically, reference coordinate system is called a global coordinate system. How we can describe this guy with respect to coordinate system that is standing still, not traveling within the motion of the system. That's what we're aiming for. And that's what we're going to do next. And this is something that is called description of rigid bodies. Assumption I do here is that the particles, these guys, are unable to move relatively with respect to each other. And that's the case only if there is no mechanical deformation. We are not dealing with mechanical deformation in this class. Later we can take that into account, but mechanical deformation is like this. Something is bending like this. We are not doing that. So we are assuming that regardless of the amount of force, this stick will remain straight line, like this, which is not what happens in reality. But later, if you're going to take my follow-up courses, you can learn how to model the deformable bodies, flexible bodies. Okay, that's where we are. Here's our challenge. I have here reference coordinate system, this guy here, and then I have a body that is called body A. The body A is a potato in the shape, and then I have just 3 particles as an example. 3 particles that are this one, and this one. Keep in mind that in reality, this consists of more than 3 particles. There is actually infinite number of those particles. But now what I wanted to do is I wanted to know where each of these particles are located with respect to this guy, reference coordinate system. That's where I'm aiming for. Okay? What are the options? One option, when I have 3 particles, I could just create the vector getting started from the origin of the body. This is a global coordinate system ending wherever the particle is located. And I can keep on repeating this until each of the particles are described. That's possible, but it's going to be very, very difficult to do end of the day, simply because if you take a close look, these are the 3 particles. And they are described by using, let me get back to this. They are described by using 3 vectors. Each of these vectors consists of 2 components, because we are looking at here a planar case, so we are not looking at the spatial case. These components are, if you take a close look about that, so there are RAX, sorry about my handwriting, RAY, which are projections in global Y, excuse me, X and Y coordinate axis. That's what it is. Same amount of components is for this guy and for this guy. So already when I'm describing 3 particles, I end up to have a total of 6 components. You know that I'm not even halfway done because I have infinite number of particles, so I should keep on doing this. And this is not possible anymore because the computers have the limit. They just cannot dealing with something that is infinite. So it needs to be discretized, something that needs to be less variables than infinite number of variables. What should I do? I need to make a use of the fact that I just mentioned in a little while back. I said that the particles cannot move relatively with respect to each other. So if that's the case, let's look at the situation again. Let's introduce something that is called body reference coordinate system. Body reference coordinate system is another Cartesian coordinate system that is very different than reference coordinate system. Keep in mind that the reference coordinate system, this guy is moving nowhere, so it's standing still. Another one is moving continuously together with the body. So this is attached to the body like this. So the body translate, the body reference coordinate system will do the same. If it translates this direction, again the same thing. If the body rotate, the body reference coordinate system will do the same again. All right, so now we have two coordinate systems. So what's the big benefit of this body reference coordinate system? The big benefit is that now with respect to this coordinate system, we can describe these particles using something that is called vector U-bar vectors. These vectors are constant with respect to this coordinate system. You still following me? Okay. Now what do I need to do? I still need to find a way to describe this U vector here with respect to this coordinate system, this global coordinate system. I need to learn the projections of the vector U bar with respect to my global coordinate system. That's what I'm targeting to. That's where really is my final mission to do this job. How can I do that then? Well, first, let's conclude that this is how I can describe these of the three particles. Now again, I have these fantastic thing that each of these vector U bars are constant with respect to body reference coordinate system. Why? Simply because the body cannot deform. It cannot deform. All right. So what next? Next, I need to find like how is that I can describe like each of these vector U bars. Like now there's one U bar with respect to this coordinate system, and it's not going to be the same than just adding up the one vector that goes to the origin of the body reference coordinate system and adding their vector U bar, because the body system can rotate all the time. And because the body system can rotate continuously, projection of the vector U bar changes with respect to global coordinate axis. So this one here is just not equal. So we need to make them equal. How is that we can do that? Well, that's pretty easy. Let's make a use of the good friend of us called Mr. Mathematics. Mr. Mathematics will come into play and will help us and make this to be possible. Okay, so Mr. Mathematics, do this. Now, we're gonna take a look at this vector U bar here. And again, keep in mind our target is this. We have to understand the projection of the vector U bar with respect to reference coordinate system. Reference coordinate system is this one here. How can we make that happen? We know that the body is already rotated amount of theta, that is this one. This is how much the body reference coordinate system is being rotated with respect to reference coordinate system. We also know that there's an angle called alpha between body reference coordinate system and the vector U bar. This is an information we can get easily, no problem. But again, still the big mystery is that what about these projections in a global x and y axes? How is that we can make those to be possible to express? Okay, now here comes some Mr. Mathematics. So we take a use of the length of vector U bar. So this is a length of vector U bar that is multiplied by cosine alpha plus theta, because these are the two angles we have to deal with. And it's going to give us this x projection. Easy, easy, not difficult. This is easy. What about the y? Same story, except of course it's not going to be cosine, but it's going to be sine. But again, the alpha plus theta, that's how we're going to make things to happen. This is only a hard lifting. So rest is mechanical. We just make use of the Mr. Mathematics. Mr. Mathematics tells us, hey, are you aware of this kind of trigonometric relation? This is what you have learned in they explain this relation already in a preschool, do they? Well, early age, you learn this kind of basic mathematical relations. Okay, I don't know when they're going to explain it, but you have heard it in high school or bachelor level courses for sure. If not, take a look at these mathematical table books or that are telling these relations. So I'm going to make use of this guy, and I'm going to substitute that information all the way back here. Okay, you're still with me? Okay? Story continues. Story continues. Then, okay, then what next? This is what I got from my previous slide. Then I'm going to make a use of comparing these projections in a body reference coordinate system. In body reference coordinate system, I have again the length of vector u bar, and then I have cosine, but not any longer alpha plus theta, but only alpha. Because look, I'm only dealing with this projection here. I'm substituting that information along with another information, which is a projection of this guy here, which is a length of the vector u bar multiplied by sine alpha. That goes back where I got from the previous slide. And when I do this substitution, this is what I'm gonna get. And this becomes to be something that is start making sense. If you look at this, you can express this using the vectors and matrices. This set of two equations can be expressed by using vector, which is a projection of the u bar in a body reference coordinate system. And then I have something that is called transformation matrix, and this is the original vector u bar. That's it. So now I have something that is called mapping, mathematical mapping. What is that I'm mapping? I'm mapping representation from one coordinate system to another. So what are the coordinate systems that I'm mapping? I'm mapping body reference coordinate system. This one, this one to this one. That's why I'm mapping. I could go another way around because what happened, what turned out to be my final result was something that is called this kind of, this one. This one actually turned out to be orthogonal matrix. Orthogonal matrix means that if you build the vectors out of the columns of these matrix, these columns are perpendicular with respect to each other. Perpendicular means that in this case they have a 90 degrees angle with respect to each other, which is a definition of orthogonality. They also happen to be unit in length, which is another positive thing. But orthogonality is a fantastic feature, mathematical feature, and because they are unit in length, they are mapping from one coordinate system to another. But because of the orthogonality, you can travel from back and forth. The difference is transpose operation. So it's simple like that, which we are not explaining in details today, but transpose operation make it happen. I know that those Jedi students that are following me right now, they are like, oh my God, really? Is it going to be this bad? No, it's going to be much worse. But this is how we're warming up. You feel that your muscles are getting warmer? You feel it? Okay, so ready to move on. This is, like I mentioned, something that is called rotation matrix. Now, last final step to take is that I need to combine this representation to something that was, something that was mentioned. This representation, we need to combine something we introduced earlier. Earlier, we introduced that there's a vector that getting started from the origin of the body reference coordinate system and ends the origin, getting started from the global coordinate system and ends the origin of the body reference coordinate system. Good. I just want to make sure that you have a full attention because something extremely important. This is something extremely important. Look, we started with the mission to describe the particles in a global coordinate system. How we're going to make things to happen is with help of this equation. This is the only equation that I'm expecting you to understand, not memorize, but understand. Rest is mechanical. This is called kinematics. Kinematics is an art of describing the particles. Rest in dynamics is based on kinematics. You can do the kinematics any way you want. There's a million different ways to do it. Now in this class we selected this one way that is based on the body reference coordinate system. There are other ways to do it. But once you have defined your kinematics, then it's just following the principle of mechanics. And you're going to end up to have an equation of motion. That's how it goes. So that's why this equation is the most important equation we're going to take a look at in this class. What do we have in this equation? We have here the vector r that leaves from the global coordinate system and goes to the origin of the body reference coordinate system. Then we have a rotation matrix that takes a rotation of body reference coordinate system with respect to global coordinate system into account. And then we have a vector u bar that is scanning every single particle within the boundaries of the body using the volume integration. That's how it goes. Okay. Here's an example. So we're going to just take a look at this one more example. And then, guess what? We're going to close today's lecture. You made it. Almost. Not yet, not celebrate yet, because we still have this one example to go. But if you're going to survive this one, you can make a big credit to yourself. So I made a first lecture. There's only 13 others to go. Good thing. Good deal. All right. So here is a beam-like body. This one here is a little bit of small description, but beam-like body. Hold on, like this one, where the body reference coordinate system is located on one end of the beam-like body. X coordinate axis is pointing upwards, Y is pointing transverse direction. And the question is that where is at the end of the beam-like body is located at this point with respect to reference coordinate system. You know, what you need to do always in multi-body system dynamics is no thinking. You're just following the certain steps and procedures, and it's going to go fine. I know that you guys are thinking clever ways that let me take a shortcut. No, shortcut here in this class is a criminal action. No shortcuts. You cannot take shortcuts. You just need to follow the same way over and over again, same way. Travel from the origin of the global coordinate system to origin of the body reference coordinate system, always. Then you take a rotation into account by using this guy here, and the last, you take the vector u bar into account. Well, remember this, vector u bar is already according to the coordinate system where the x is pointing upwards, okay? So information we have here is that the r is mentioned. So it's a matter of substitution, like this. What else is mentioned? It's mentioned that the rotation is p divided by 2. So you substitute that information here. The only thing left, what about the vector u bar? It is mentioned that the body is 1 unit in a length. 1 unit in a length. So you need to travel along the body x coordinate axis, amount that is 1. How much you need to travel this direction, that's 0. And when you do the math, you have the final position that is 2, 2. Now, the last thing is this. Are we going to score 100% in our second in-class quiz? What do you guys think? Is it going to be 100 or is it going to be even 110? Okay, this one, let me take a look. Not the multi-body system. What is not the multi-body system? Biomechanical system, robotic system, front suspension of the affordable car, simply supported beam. Is it going to be 100%? No? Yes, it's going to be 100%. Okay, front suspension is a multi-body system. It is, because there are moving bodies, and bodies are connected together via joints. These guys that are fixing their car, they can give a lecture about how you can take these joints away and how you can handle that. What else? Biomechanical system, yes, it is. Of course, that's a good one actually, because in a biomechanical system, we usually assuming these joints to be ideal constraints. In reality, they are not, but they can assume to be ideal joints. Are you coming back next Monday, or this is it?
No choice.
If you can still find this place, welcome back. Okay, guys, the door is located in that direction. So I can, if you need any help, just raise your hand and I can walk you out. See you guys on Monday. Just a second, I'm gonna close this one.